In this demo, we'll show how SIP system helps sensor network operator better diagnose salient network failures. To start, the user opens dataset from processed archives. He picks a half-day data. Then the data is loaded to the system, and several of this data structure is computed online. Next, the user switches to the Save main panel to start the data navigation. Save multi-view visualization is then presented. The major view in top left renders the temporal expansion graph showing the routing topology. On the right side, there is a dimension projection view to visualize the distribution of multidimensional sensor data. On the bottom, several special-purpose views are attached, including the Eagle view, correlation graph view, and the detailed trend charts. The system also supports various configurations and built-in analytics algorithms. However, in this demo, we'll only highlight the variants of visualizations. Back to the current case, the user proceeds by drilling down to the sensor node 543 as he perceives a significant outlier in no parent dimension, which is critical to the sensor routing. He further selects this dimension to retrieve the numerical data trends, where he validates a burst here. He then turns to the Eagle graph view to get more details of its routing paths. He gets confirmed this sensor has experienced various route changes. He also notices from the centered time slider that there is a blank time period where the sensor does not send out packets. To focus to the hotspot, he refined the time range to contain exactly this period. From the correlation graph in delta mode, he finds the no parent symptom also relates to several other events. To get a better view, he uses the filter to remove the low-strength correlations. He further switches to the current mode of correlation graph, where clearly task post, task execution, and task send fail are critical dynamics. He selects these dimensions for details, as he expects there's an anomaly surfaced as increasing failed tasks, while correlated with tasks issued. He also selects other dynamic dimensions and filters out the other unrelated ones in the dimension projection view. From the Eagle graph view, he infers that sensor 543 is not the source of the problem, since there is no root change here. To further locate the root cause, he clicks on the sensor 401, the first one with root dynamics. 3 anomaly counters detected from the correlation graph are selected for sensor 401. Numerical trend cards show that a link failure may be the problem due to the many unactioned requests. He also reorders the projection dimension circle to get these 3 correlated dimensions together to identify a class of failure. To further prove whether the problem is with the link, he steps forward to the next sensor, 457, on the path. The 3 chosen indicators in sensor 457 suggest it as a healthy node. There is no significant correlation graph change on warning indicators. Transmit no act retransmit is actually with decreasing correlations to the other statistics. He also switches to the flight time graph view, where he is informed clearly. The sensor 457 is in normal state. Finally, he concludes that the root cause for the no parent symptom of sensor 543 is actually the link failure between sensor 401 and 457.